Okay, students, now let us start with. So, the subject is design of RCC structures, and in this, please refer as we have already discussed the objectives of this course is to make our students aware regarding the analysis and design of reinforced concrete structures, their behavior, and what is reinforced concrete structures, what is concrete, everything we will discuss one by one. And the course outcomes at the end of the syllabus, you will be able to understand the behavior of concrete structures. You will be able to analyze and design the structural components. You will be able to have hands-on experience of structural calculations also. So these are the reference books, students. You can access those from our library, or you can refer online source, whatever you feel comfortable for this subject. And already I have also uploaded in your classroom the material, course material content developed by me. So reinforced concrete design by Pillai and Menon, Tata McGraw-Hill. Reinforced concrete limit state design by A.K. Jain. Reinforced concrete volume 2 by H.J. Shah, Charotar publisher. Then RCC designs by B.C. Punmia. This is the textbook, you can call it as a reference book, which is referred by most of the consultants, engineers, students in India. So you can refer B.C. Punmia also. So these are few books which you can refer for this subject. In this subject, students, in first unit, we are going to cover these following topics: introduction, what is concrete, what is reinforced concrete structure, what exactly is the reinforcement, what are the various methods to analyze concrete structures, working stress method, ultimate stress method, limit stress method. Nowadays, we are adopting limit state method. Working stress method was used earlier. These methods were used by engineers decade before. Now we are adopting limit state method. What is the difference between these methods and why we are adopting limit state method of RCC design? Everything we will learn. Then singly reinforcement sections, doubly reinforcement sections, assumptions in designing of structures, everything we will learn one by one. So in the presentation which I have uploaded in your classroom, students, all these portions, or you can say these topics, are covered. Now see this image. Can anyone tell me what is this? You might have seen um, many a times such types of cage, you can say, during construction. So can anyone tell me what we call it as? In civil engineering, we call it as reinforcement. Reinforcement. What exactly reinforcement means? See, when this is a beam, suppose you can call it as, suppose this is a beam, and in this beam we are using, I am using black color, generally reinforcement like this, right? So this is the front view, right? This is reinforcement. Reinforcement means actually they are steel bars. They are steel bars. These are the steel bars. Now, such types of, in later stages you will come to know, these are known as stirrups. So this is the front view. Actually I am trying to draw here the front view, and if you will look at the three-dimensional view, the actual picture, it is like this. If you are standing here and you are observing this, that is from front view, then you will not get this. You will be able to see this horizontal reinforcement and these vertical stirrups like this, which I have tried to show here. So this is known as reinforcement. Reinforcement means something when you are inserting reinforce, or reinforcement, right? So reinforcement or reinforce means there will be concrete body, and within the concrete body such types of steel bars will be introduced, will be inserted. And you know, when concrete will be filled and it will set, then you will get hardened structure. Either you may call it as beam or column. And after setting, you will not be able to see these steel bars or reinforcement, right? You might be observing wherever you are sitting right now. You please look at your beams and columns. You will not be able to see the cage or steel bars or reinforcement. No, you will see only concrete, because concrete, when it gets set, everything these steel bars comes within that body. So this we call it as reinforcement. Reinforcement means something to be introduced within the concrete body. And when these steel bars and concrete structure is there, we call it as reinforced concrete structures. Reinforced concrete structures means we call it as RCC structures. RCC structures means reinforced cement concrete. You may use any type of cement, you may use any grade of concrete, you may use any type of steel bars. Later in further classes you will come to know, but we call it as RCC structures. So RCC structures means reinforced cement concrete structures, which comprises of concrete and steel bars. So these RCC structures are mainly columns, beams, retaining walls, foundations, everything, whatever the type of foundation is. It may be a raft foundation, whatever it is, all these are RCC structures. And concrete, you know very well, concrete means cement plus sand plus aggregate plus water, or you may call it as cement as a binding material plus fine aggregates, sand or any other fine aggregates like crushed dust, coarse aggregates, and water. So this is RCC, reinforced cement concrete structures. In this subject you have to learn how to analyze and design concrete structures. Then PCC. PCC means plain cement concrete. Plain cement concrete means what? There will be cement, sand, aggregates and water. But steel bars or steel reinforcement will not be there. So it is PCC. Generally in flooring or when we lay down tiles, right? So first of all, we prepare PCC, plain cement concrete. Over that PCC, we lay down the tiles and marbles like this. So this is PCC. So PCC and RCC, these are the abbreviations generally we use in civil engineering. Then here this reinforced concrete is called as a composite material. Composite material means combination of various materials having different properties. Cement has different properties, sand has different properties, right? Aggregates have different properties, steel bars have different properties. When you mix cement, sand, aggregate along with water, you get RCC, concrete, reinforced cement concrete along with steel bars or reinforcement you are using. Because of cement and because of the addition of water, this cement binds every material and we get one component as a whole. So we call that component is made up of composite material. Now this composite material RCC or reinforced cement concrete has several advantages. It's superior in performance. Earlier, 50 years before, 100 years before, what humans were doing? They were using stones, timbers, wood materials for their construction of houses. It was not possible to construct with those materials those days, what we can say, skyscrapers, tall buildings. No. With the ability of this composite material, nowadays we are able to construct tall buildings. We have several attractive plannings and structures which we have prepared and we have constructed, and now also today also we are able to construct tall buildings. Lot of flexibility is being offered to us because of this composite material. Bridges and enormous multi-storied frames and huge structures we have constructed because of this material. So students, concrete is actually artificial composite material. It is a mixture of cement, sand, gravel, water, but mixture should be in determined proportion. It should not be like that. If proportion gets mismatched, your structure may fail. Why you have thorough knowledge of this subject? Being an engineer, you should be able to determine proper proportions. We call it as mix design. What should be the proportion by weight of cement, of sand, of aggregate? What should be the quantity of the water? So, all these things you should know properly in order to determine good concrete. The quality of concrete should be good, it should be serviceable, it should be such that the structure which will be constructed with the help of concrete, that should be at least last for 50 years. So students, I hope that the introduction to RCC structures is clear to all of you. Thank you very much.